name, okay? And IUPAC stands for the International Union of Pure and Applied Chemistry. Now, a lot of you guys that want to go into medicine, pharmacy, and the like, you know that anytime you've got a drug, they've got drug classes, okay? For an example, you've got the SSRIs. That consists of what? Your Zolofts, your Paxils, your Lexapro, your Celexa, all these type of quote-unquote happy type drugs, right? And then you've got your benzos. That would consist of something like Xanax. And then, of course, you've got your opioid derivatives, things like morphine, Dilaudid, whatever. Well, chemistry is the same way for inorganic compounds. And the first one that she talked about was, what would happen if you had yourself a metal bonded to a non-metal? Okay. Now, that is an ionic compound, which we talked about as far as bonding. An example of that would be NaCl. Another example of that would be MgCl2. How would you name this? This would be sodium. Now, how do you know to pick sodium? Well, you pick the English name off the periodic table as written when it is the first letter or first two letters. The second one is a chloride. So that means everything within this class ends in an IDE. So you take the chlorine, get rid of the INE, and put an IDE on it. On the second one, this right here is magnesium chloride. Okay, and this is typical. These are binary compounds. Binary, bi means two, right? Bisexual, you like the male and the female, that's two. Binary, two different atoms, right? You've got atom 1 and atom 2. Now here you may say, wait a minute, King, there's 3 atoms there. Yeah, I know that, but there's only 2 different ones. Number one thing, they all end in an IDE. Now the second thing that Mary talked about was what would happen if you had something like a metal bonded with a non-metal. All right. What am I doing? I don't know. By the way, I can't see today. So you guys will have to forgive me. Metal bonded to a polyatomic. I have no idea how I'm going to give this lecture, so we'll just see how things go. Okay, what's an example? Well, you've got something like BaNO3, 2. You've got something like Na2SO4. Now wait a minute, what's all this about? Well, there's a master list there. In the back of your textbook, on the very back page, back there where you got cardboard, is basically chapter 6 on one page. Now there is no verbs, there's no paragraphs, there's no explanation for you. That's your memory. Okay? If you want an explanation, well, you come to class, you listen, and of course you read chapter 6. This right here, the back page, is a good cheat sheet. Alright? Now, what have we got here? Well, an NO3 minus is called a what? Nitrate. Alright, so this is barium nitrate. And the SO4 minus is something that's called sodium what? Sulfate. Now, what is characteristic here? Polyatomic. Many atoms, right? NO3, many atoms. SO4, many atoms. Now, this is brute force memorization. Girl called me from the Friday class. Is there any tricks? Is there anything we can know? The answer is no. There's not. You just have to know that. Now, let me talk for just a minute about a few tricks, right? Because I have not watched the video. I have no idea what Mary talked about. But here's what we got. An SO4 2 minus is called a sulfate. And an SO3 2 minus is called a sulfite. And an NO3 minus is called a nitrate. And an NO2 minus is called a nitrite. Now, don't nobody look at the table. What is a BO3 3 minus called? Borate. All right, and what's a BO2 3 minus called? Borite. Okay, so let's start generalizing, right? Because a good scientist is always looking for patterns. First off, what is not a pattern? Every sulfate has 4 oxygens. That ain't going to work for you. Every 8s have 3 oxygens. that ain't going to work for you. But here's what you can say. If I spend enough time and energy to memorize all of the things ending in ATE, all of the things ending in ITE have only one less oxygen. All right? So if you memorize every 8 there, iodate, the iodite would have one less oxygen. Borate, borite, one less oxygen. Bromate, bromite, one less oxygen. Now that doesn't make your life easy, that just makes your life easier. All right. Now let's talk about this, right? I went to the eye doctor yesterday. I'm not sure that Mary told you what the problem was. And my eye doctor, he's kind of a funny guy, and he has these easy buttons sitting around, right? When all you got to do is push it, well, there's no easy button in chemistry. But let's see here. What's a ClO3 minus called? Chlorate. Now, one less oxygen would be a what? ClO2 minus, which is a chloride. All right, so look at here. You're going to the hospital, and you're going to the hospital because you are, for some reason, not getting the oxygen you need in your body. What's the high-dollar word for that? What's that now? Hypoxia, right? You're hypoxic. So what does hypo mean? Low. Low oxygen. This is hypochlorite. Right? Like if someone has hypotension, what you got going on? Low blood pressure. If you got hypothermia, you got low body temperature. All right? If you're hypoglycemic, you got low blood sugar. Now let's go the other way. What if you go into the hospital and you're hyperventilating? What's going on? You have too much what in your body? Hyper is too much what? Oxygen, right? So they tell you to do what? Breathe in the paper bag. What are they trying to do? They're trying to circulate carbon dioxide in your body to lower that oxygen level, right? If you get overly excited about some random gene thing or another. So one would expect this would be called a hyper what? Chlorate. Well, us chemists, we're silly. We don't use the high part. This is just called a perchlorate. Okay? But historically, the hyper was there, right? Hypertension, I got high blood pressure. Hyperchlorate means I got high oxygen content compared to the chlorate moiety. Now these go all the way through, right? What's an IO3 minus? If this is a chlorate, that is a iodate and an iodide and so forth. You can do that for all the halogens. Now some of the oxidation states for the halogens have been unobtainable thus far, okay? But in theory, as far as naming goes, you could go through all of that. So that's what happens if you got yourself a metal with a polyatomic. Reaction scheme number 2. Now the third one that she talked about was what would happen if you had 2 nonmetals. So that means a nonmetal bonded to a nonmetal. Now what type of bond is that going to give you? Covalent bond, right? Examples of that would be N2O4. Now take a look at this. We don't reduce here. Did we reduce over there? What if you had calcium sulfide? And calcium sulfide looked like this. Would you reduce that? Yeah, you would. Why? Because there's a metal present. Calcium sulfide is this, CaS. Anytime there's a metal in that formula, you have to reduce it. Is there a metal up here? No, so you don't reduce it. This thing here is called dinitrogen. What? Oh, yeah, sorry, not penta. Tetroxide. Okay. Now, if you reduce this to NO2, this is a totally different compound that can be put in a totally different glass vial or glass reaction container. What's the name of this joker? Nitrogen dioxide. Right? Same way with CO2. This is called what? Carbon